Okay, today's lecture is on hydrogen atom. The solution of hydrogen atom by Schrodinger method. Today's solution of hydrogen atom by Schrodinger method. Hydrogen atom or hydrogen like atom. First of all, what is hydrogen atom? So, hydrogen like atom, the hydrogen like atoms or hydrogenium hydrogenic atom is a two particle system consisting of an electron of charge E mass m moving around the nucleus of charge plus Jd. This is the hydrogenic atom. There is only one electron, very important, only one electron in the outermost orbit, and in the nucleus there will be a charge Ze. Z is the atomic number, Z is the atomic number of the atom. But if this is hydrogen atom, then there will be one electron outside the orbit, but in the nucleus there will be one proton also, the Z will be 1 for hydrogen atom. So, we will solve the hydrogen atom problem by Schrodinger or hydrogenic atom by Schrodinger equation of method. Achha. So, this is the picture of an hydrogen atom. This is the nucleus or hydrogenic atom nucleus with charge plus Ze. This is the electronic orbit. This is the electronic orbit, this is the radius, r of the electron, and electron or charge E mass m. This has the coordinate x1, y1, z1 with respect to a particular origin, and this nucleus has coordinate x2, y2, z2 with respect to a particular coordinate. So, this is the nucleus, this is electron, and this is the orbit radius, r is the radius of the electronic orbit, x1, y1, z1 is the coordinate of the electron with respect to a particular coordinate system, x2, y2, z2 is the coordinate of the nucleus with respect to a particular coordinate system. And nucleus is a positive charge, electron will be negative charge. So, there will be a Coulomb attraction between the nucleus and electron, and this will gives an potential energy of the electron. So, there exists Coulomb interaction between the nucleus and the electron. Coulomb interaction between the nucleus and electron and the potential energy of the system V of r, this is equal to minus Z in the charge of the nucleus into E charge of the electron divided by r minus Z E square by r. This potential energy is negative because there is a Coulomb attraction between the electron and the nucleus, and this potential energy is independent of theta and phi. That is, the potential energy is independent of theta and phi. It has spherical symmetry means it has only dependence on r, and with variation in theta or phi there will be no change in potential. So, these two particle system, one is electron and other is nucleus, we can write total Hamiltonian of the system, as HT, T for total Hamiltonian of the system, and this symbol, cat symbol or hat symbol, this is for operator symbol. So, total Hamiltonian of the system HT, this is equal to minus H cut square by 2m1 Laplacian operator 1 square minus H cut square by 2m2 Laplacian operator is square 2. So, this Laplacian operator, this is the kinetic energy part of the electron and this is the kinetic energy part of the nucleus. One is for electron because the orbit coordinate of the electron has been designated by x1, y1 and z1, and 2 for the nucleus because the coordinate of the nucleus has been denoted by x2, y2 and z2. So, this is the kinetic energy part of the electron and nucleus. Then there will be potential V function of x1, y1, z1, x2, y2 and z2. So, minus h cut square by 2 gradient 1 square by m1 plus gradient 2 square by m2 plus v x1 y1 z1 x2 y2 z2. M1 and M2 mass of the electron and nucleus respectively. And Laplacian operator on square, this is equivalent to del 2 del x1 square del 2 y1 square del 2 del z1 square, and Laplacian operator 2 square, this is equal to del 2 del x2 square del 2 del y2 square plus del 2 del z2 square. Acha. Okay, this is the total Hamiltonian of the two particle system, and we now write down the Schrodinger wave equation for the system. The Schrodinger wave equation for the system is H operator psi t, this is equal to H psi t equal to E t psi t, where psi t is the wave function of the total system, where psi t wave function of the total system, and it is the total energy, Et is the total energy of the total system. This is the Schrodinger wave equation. Now, if we write down the expression of Hamiltonian elaborately, then we get minus a square by 2m1, a square by 2m1, then del 2 psi t by del x1 plus del 2 psi t del x2 x1 y1 y1 square plus del 2 psi t del z1 square, then minus a square by 2m2 del 2 psi t by del x2 square plus del 2 psi t del y2 square plus del 2 psi t del z2. This is a kinetic energy operator plus potential V function of x1, y1, z1, x2, y2, z2 minus Et has been taken the left side, Et psi t, this is equal to 0. So, this is the elaborate expression of the Schrodinger equation for hydrogen or hydrogenic atom in Cartesian coordinate system. And potential energy of the system is a function of 3 coordinates of the electron and 3 coordinates of the nucleus. Now we define 3 relative coordinates small x, this is equal to x1 minus x2. x1 minus x2. This is the coordinate x component of the electron, coordinate of the x component of the coordinate of the electron with respect to the nucleus. Y equal to y1 minus y2 and z equal to z1 minus z2. These are the coordinate of the electron with respect to the nucleus, coordinate of the electron with respect to the nucleus. Now we also define, these are the relative coordinates of the electron with respect to nucleus. Now we define three coordinates x, y, z of the center of mass capital X. This is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Because there are two particle system, one is electron and other is nucleus, we can define the center of mass. This is the coordinate of the electron with respect to the nucleus, and this is the coordinate of the center of mass with respect to a particular coordinate system about which x1, x2 has been determined. So, capital Y, this will be equal to m1 y1 plus m2 y2 divided by m1 plus m2, and capital Z, this will be equal to m1 z1 plus m2 z2 divided by m1 plus m2, where capital M equal to m1 plus m2. Now introducing this new 6 variable x, y, z and capital X, capital Y, capital Z. এই ছটা variable, introducing these new 6 variables and assuming psi t, this is equal to function of psi x, y, z, capital phi, function of capital X, capital Y, capital Z. We can separate the Schrodinger equation like this: minus a square by 2 mu, a square by 2 mu del 2 psi by del x 2 plus del 2 psi by del y 2 plus del 2 psi by del z2 plus potential V, function of x, y, z psi, this is equal to E psi. So, we will introduce this variable x, y, z and variable capital X, capital Y, capital Z. These are relative coordinate of electron with respect to the nucleus. It is the coordinate of the center of mass of the electron and nucleus, and we also assume the psi t as a product of psi, which is a function of only relative coordinate of the electron, and capital phi, which is a function of the center of mass. And putting this in this Schrodinger equation, we can, after a little bit of mathematics, a little bit of calculation, separate this equation into these two equations: a square by 2 mu del 2 psi del x2 plus this kinetic energy part plus potential energy part. Mu is the reduced mass of the two particle system. Reduced mass of the two particle system, and another equation will be minus h square by 2 capital M del 2 phi by del x2 plus del 2 phi del y2 plus del 2 phi del z2 plus equal to minus Et minus capital E phi. This is equal to 0 where E is a constant. Okay, this is one equation and this is another equation. Now, for reduced mass for two particle system of mass m1 and m2, for a two particle system of mass m1 m2, reduced mass 1 by mu, this is equal to 1 by m1 plus 1 by m2. This is equal to mu equal to m1 m2 divided by m1 plus m2. And if we divide by m2, then m1 divided by 1 plus m1 by m2. This is equal to approximately m1 when m2 is very greater than m1. So, for a two particle system of mass m1 and mass m2, reduced mass mu will be like this, and when one particle mass has very less compared to another particle mass, then reduced mass mu will be nearly equal to the mass of the lighter particle. This is very important. For two particle system, reduced mass is nearly equal to the mass of the lighter particle, and where capital M is the mass of the total two particle system, and for two particle system, total mass concentrated at the center of mass. So, and center of mass is very close to the position of the heavier particle. So, capital M will describe the motion of the nucleus or heavier particle, and this equation will describe the motion of the reduced mass of the particle, that is the electron of the system. So, in this equation we have the potential wave function which is describe both the motion of the electron as well as the nucleus, and introducing the 6 variable and assuming wave function as a separation of these two function as a product of two function, we have obtained these two equation. One equation is for the electron and another equation is for the nucleus, and as electron is more lighter than the nucleus, so we will concentrate on this equation, particular equation which will describe the motion of the electron. Now, this is the equation for the electron in the Cartesian coordinate system, equation of the electron in Cartesian coordinate system to describe the motion of the electron. Now as the potential has spherical symmetry, we will convert this equation in spherical polar coordinate system, and spherical polar coordinate system is like this. This is origin x, y, z. This is particular point in Cartesian coordinate x, y, z in spherical r, theta, phi. This is radius r, this is theta, and this is phi. So, z, so relation between x, y, z and r, theta, phi is that x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z this is equal to r cos theta, z equal to r cos theta. And using this relation between Cartesian coordinate and spherical coordinate, we can transform the Schrodinger, and we have the Laplacian operator. Laplacian operator, this is equal to 1 by r square del r square del r plus 1 by r square sin theta, then del theta sin theta del theta plus 1 by r square sin square theta del 2 del phi 2. This is the Laplacian operator in three-dimensional spherical polar coordinates, and Hamiltonian operator will be like this. For Hamiltonian operator for electron, minus h square by 2 mu. Mu is the reduced mass of the two particle system, but basically it determines it is very nearly equal to the mass of the electron. Minus a 2 mu Laplacian operator is square plus potential V of r. So using this expression, we can write the Schrodinger equation for the electron like this: minus h square by 2 mu Laplacian operator psi, Laplacian operator psi plus potential V psi, this is equal to E psi. Or Laplacian operator psi minus 2 mu by a square V psi, 2 mu by square is a V psi equal to minus 2 mu by a square E psi. Okay, now if we write the expression of Laplacian operator explicitly in three-dimensional Cartesian, three-dimensional polar coordinates, then we can write 1 by r square del r square del psi del r plus 1 by r square sin theta del theta sin theta del psi del theta plus 1 by r square sin square theta del 2 psi del r2, sorry, del phi 2 plus 2 mu by a square capital E minus V psi, this is equal to 0. We have taken this from right side to left side. So this is the expression of Schrodinger equation for the electron in three-dimensional polar coordinates. And as the potential V does not, this is equal to minus z e square by r is explicitly independent of time. The potential is explicitly independent of time. We can separate this equation by, we can solve this equation by the method of separation of variables. This is very important. When to solve Schrodinger equation, when the potential in the equation is explicitly independent of time, we can solve the equation by the method of separation of variables. By the method of separation of variables. By the method of separation of variables. And in the method of separation of variables, let psi function of r, theta, phi. This psi is a function of r, theta and phi, 3 coordinates, and we can write it as capital R, which is only function of small r, capital theta, which is only function of small theta, and capital phi, which is only small phi. This capital phi is the one part of the wave function. We describe the motion of the electron. This is another part of the wave equation. We describe the motion of an electron. This is another part of the wave function. We describe the motion of the electron. So, by the method of separation of variables, when potential energy of the electron is explicitly independent of time, we can assume the wave function of the electron like this. And assuming this, we can write, we can find del phi del r. We can write phi del psi del r. This will be like this, d capital R by dr capital theta capital phi, and then we can multiply it by r square. We can multiply it by r square and take the partial derivative of this. We can take partial derivative of this term. So, we can get this term. Similarly, we can also find this term and we can also find this term, and when we put these 3 terms in this equation, and dividing it by r square sin theta. I repeat this step. First we assume psi equal to capital R, capital theta, capital phi, product of 3 variables. Then we will find del del r, r square del psi del r, del theta, sin theta, del psi del theta, and del 2 psi del phi 2. We will put these terms in this equation and divide throughout by r square sin theta. Then we will get sin square theta divided by capital R d of dr r square d capital R by dr plus sin small theta by capital theta d of d theta sin theta d capital theta by d theta plus 2 mu r square, 2 mu r square sin square theta divided by a squared square e minus v plus 1 by capital phi d2 capital phi by d phi 2, this is equal to 0. So, now sin square theta divided by capital R d of dr r square d capital R by dr plus sin theta by capital theta d of d theta sin theta by capital theta d of d theta sin theta d capital theta by d theta plus 2 mu r square by a square sin square theta e minus v, this is equal to minus 1 by capital phi d2 capital phi by d phi 2. So right hand side, this is a function of only phi. This is right hand side, this is a function of only phi, and this part is a function of theta and r. So left hand side of the above equation is a function of theta and r. This is independent of phi, and right hand side is a function of phi only. This is independent of theta and r. So left hand side of the above equation, this is theta r, this is theta, this is r theta. There is no phi in the left hand side. Left hand side of the equation is a function of theta and r. It is independent of phi, but right hand side is a function of phi only. Right hand side is a function of phi only, and it can be possible only when both sides are equal to a constant, say this constant is say m square. For simplicity we have taken it as a square, we can also take it as a m, but for simplicity we have taken it as a m square is a constant. So we can write minus 1 by capital phi d2 capital phi by d phi 2 equal to m square. This phi equation is called azimuthal equation for the electron. Then we will get d2 capital phi by d phi 2 plus m square capital phi equal to 0. And immediately its solution will be like this: capital phi, this is equal to some constant a e to the power I m phi. A is a some constant. We can also write as a plus minus I m phi. constant, this is called normalization. And capital phi has to be single valued. So phi at a small phi equal to 0. This is equal to capital phi at small phi equal to 2 pi. So capital A e to the power I m0, this is equal to capital phi I m 2 phi, capital A. So this is equal to 1 equal to e to the power I m 2 pi. So this is equal to cos m 2 pi plus I sin m 2 pi. So cos m2 pi will give 1, cos m2 pi will give 1 when m is an integer, and sin m2 pi will give 0 when m is an integer. So from this equation we can find that m is an integer, having values m equal to 0, plus minus 1, plus minus 2, plus minus 3, dot dot like this. And this m is called magnetic quantum number. M is called magnetic quantum number. And using the condition of normalization, as capital A e to the power I m phi has to be normalized, and using the condition of normalization, integration capital A capital phi star capital phi star capital phi d phi, this is equal to 1 phi from 0 to 2 pi, as the total probability of the radial part is azimuthal part will be equal to 1. So 0 to 2 pi phi star phi d phi, this is equal to 1. So this immediately give us mod A square 0 to 2 pi d phi equal to 1. So mod A will be like, from here we can get 2 pi, so this is equal to root over 1 by 2 pi. So total solution for the azimuthal equation, total solution for the complete solution of the azimuthal equation is that capital phi this is equal to A equal to 1 by root over 2 pi e to the power plus minus I m phi. This is the total azimuthal part of the equation. Now we are left with this equation. We have find the complete solution of the azimuthal part capital phi, and we are left with to find the expression was capital R and capital theta, capital R and capital theta. We have to left to find out these two expression. So we can write this like this, just sin is, we can also begin from this equation, sin is square theta divided by R d of dr R square d capital R by d small r plus sin small theta by capital theta d of d theta sin theta d of capital theta by d theta. Capital theta by d theta plus 2 mu r square by h cot square sin square theta e minus v equal to m square. So, we can divide this equation by sin square theta, then we will get 1 by r d of dr r square d capital R by dr plus 1 by sin theta capital theta d of d theta sin theta d capital theta by d theta plus 2 mu r square by h cot square sin divide করে দাও capital E minus V, this is equal to m square by sin square theta. So, this part is independent of r, this is only depend on theta, this part only depend of theta, this part depend only r, and this part also depend of r. So, we can keep in the left hand side on the r dependence part, and we can take in the right hand side the theta dependence part, then we can get 1 by capital R d of dr r square d capital R by dr plus 2 mu r square capital E minus V divided by h cot square, this is equal to m square by sin square theta minus 1 by sin theta sin capital theta d of d theta sin theta d capital theta by d small theta. So, again this left hand side is a function of r and this is the function of theta, and they are equal, and it is possible only when we take it as a constant. This constant is say lambda. In this case separation constant is lambda. Lambda is the separation constant. Then we will get 1 by capital R d of dr r square d capital R by dr plus 2 mu r square by h cot square capital E minus V, this is equal to lambda, and after simplification we will get 1 by r square d of dr r square d capital R by dr multiply both side by capital R by r square, then this will be 2 mu by capital R h cot square then E minus V minus lambda capital R by r square equal to 0, and and when then 1 by r square d of dr, r square d capital R by dr, and if we take 2 mu by a square E minus V minus lambda by r square here lambda will be in the numerator, r will be in the numerator. So capital R, this is equal to 0. This is the radial part. This is the radial part of the wave function of the electron, radial part equation of the wave function for the electron. Now we are left with the theta dependence part. Theta dependence equation will be like this: m square by sin square theta minus 1 by capital theta sin theta d of d theta sin theta by d capital theta by d theta. This is equal to 0. Sorry, this is equal to lambda. Or 1 by capital theta sin theta d of d theta, then sin theta d capital theta by d theta. We are writing this term in the first minus m square sin square theta equal lambda capital theta. This will be minus lambda, and if we multiply capital theta, then we will get 1 by sin theta d of d theta sin theta d capital theta by d theta minus m square by sin square theta d capital theta lambda capital theta. And this will give us, if we take it from the in the left side, we will get 1 by sin theta d of d theta sin theta d capital theta by d theta plus lambda minus m square by sin square theta capital theta equal to 0. So this is the theta dependence part. This is the theta dependence part of the wave function of the electron. Now we will concentrate on these two equations. This is the radial the equation of the wave motion electron, and this is the theta dependence equation of the electron. And now we will solve the solution of the polar equation. Solution of theta dependence equation is called polar equation. So we will concentrate on the polar equation. Solution of polar equation. To solve this equation, first we will convert in another form which is very familiar to us, and we introduce a new variable, let x equal to cos theta. Therefore, when theta equal to 0, x equal to 1 and theta equal to pi, so x will be equal to -1. So between the theta limit, theta lower varies from 0 to pi, x varies from +1 to -1. Now d dx d theta, we can write like this, dx d theta, this is equal to minus sin theta, and d capital theta by d theta, this is equal to d capital theta by dx into dx d theta. So, d capital theta dx equal to minus sin theta d capital theta by dx. So, d of d small theta equal to minus sin theta d of dx.